Okay, we have Crohn's disease here, which is a disease that has some intestinal implications. It's relatively rare in the U.S., but we have a prevalence of about 0.18%. Okay, so that's not 18%. That is 0.18%, is less than 1%. It's 18 hundredths of a percent. And the population of the U.S. is around 324 million. So, in order to find out about how many people in the U.S. suffer from Crohn's, I look back at my prevalence. And I know that this percentage of the entire population is the number of people who are going to suffer from Crohn's. So, the first thing I'm going to do is convert it to a decimal, move the decimal 2 places, so 0.0018. And then I'm going to multiply that by 324 million. So, that's 324 million in expanded form. So I get a little over 500,000 people here, 583,200 people who actually have it. Okay, and we have a sensitivity here of 80%, specificity of 90.2%. So when I start thinking about these people who have the disease, since this test is 80% sensitive, it's going to find 80% of these people who have it. So I said 0.8, which is 80%, times about the 500,000 people. Somewhere around 466,560 people will get a positive test, and they do have Crohn's. Okay. The rest of those 500,000 people, this other 116,640 people, they're going to get a negative test. Okay. And that is a false negative. They actually do have Crohn's, but they're going to get a negative test. Okay. Now, what about the people who don't have it? Okay. Where do we come up with this information? Well, first of all, I know that I had 324 million people. About 500,000, little more than 500,000 of them have this condition. So that means this other 323 million or so people don't have it. Okay. This test is 90% specific, 90.2. So if I convert that to a decimal and multiply by those other people, okay, I'm going to come up with about 31,694,846.4, okay, who do have this, and about the 291,721,953.6 people who don't have it, okay, and that comes from my specific calculations. That's going to be 90% of those leftover people. Okay, this number, okay, is this minus this. Okay, the people who didn't have Crohn's that are going to get their negative test correct. These are true negatives. Okay, and these people, this is the point. This is the 9.8% that is going to get a false positive. Okay, if we know it's going to find 90.2, this is the percent that it's not going to properly identify as negative. Okay, let's scroll on down here. There are about 33 million people in the U.S. who show symptoms of Crohn's disease. If we know that this group had a PPV of 63%, what conclusions can you draw? Okay, we should be really worried about false positives. The lower the PPV, the more false positives we have. So in this case, if we start getting a low PPV, we're going to have a lot of people who get positive tests who really don't have the condition. Now, what's kind of wrong with that? Well, they're seeking out and paying for treatment that they don't need. It's possible that treatment could be of some risk to them. So it's never a good thing to receive treatment or think you have a condition that you don't have. Okay, it's not a just-in-case situation. Having a low prevalence of a disease can make some medical tests problematic. Why? We get excessive numbers of incorrect results. Okay, we treat people who don't need it, and it's possible that we don't treat people who do need treatment. So whenever there's a low prevalence, it just sort of increases the odds that we can make some mistakes there. Okay, PPV and MPV are examples of conditional probability. You want to know what that means? Conditional probability is probability that depends on something else being true. Okay, so conditional probability is calculated by we can calculate it the same way we've always thought about it. But whatever the condition is what affects our total. Okay, we've always thought about probability as success out of a total. But that condition sort of redefines what the total is. Okay, so let's kind of think about that in action here. If we're given this table of information, it asks us what is the conditional probability that someone tests positive given that they have TB. Okay, anytime we see the phrase given that, that's usually what's telling us the conditional probability. So instead of now looking at an entire group of people, we've redefined our total to be people who have TB. Okay, that's our condition and that's our total. Now, in this piece of information, where does that come from? We have a number of 662 here. That comes from this entire row. We added these up together, okay, because that's the total of people who have TB. So they've become my new total. Now, what portion of them am I interested in? The testing positives. Okay, so this is my whole group that have TB. My test positives are 446. So when I look at that, it's about 67%. Okay, it's about 67% in this case. Conditional probability redefines your total for you. So whatever we're given that's your new total that you're looking at the portion of. Okay, so we can think about it as a traditional way to calculate it, but we just have to think about it as redefining what our total